Hello, my name is Muhammad Salim Beso Khairi. My numeric is 061890. Alright, our team chose instruction pipelining as our assignment project. So, what is pipelining? Pipelining is the process of accumulating the instruction from the processor through a pipeline. Thus, it allows storing and execute the instruction in an orderly process. Next, the process of this fetch mechanism is to enhance the performance of the processor. Why? It is for the user who need to make a heavy duty like editing or coding on their PC. Alright, and then topics that we highlight in our project is the structure of pipelining, designs and architecture, and advantages and disadvantages of pipelining.
My name is Muhammad Zahid bin Zubair and my matrix number is 060560. In 1960, people needs for faster and more cost-efficient system. Instruction of pipelining helps to match the speeds of various subsystems with less cost. Faster and cheaper LSI circuits become available today. Computer hardware simultaneously processing more than one basic operation in a time within two well-recognized techniques, which is pipelining and parallelism. The main goal of designing a computer pipelining is clearly performance. Pipelining splitting the function to be performed into smaller pieces and allocating separate hardware to each piece termed a stage. Pipelining is designed to execute the same function repeatedly. A computer pipeline may do more and simply move the contents unchanged from one location to another. A computer pipeline may have stages devoted to instruction to fetch, decode, and execution.
My name is Muhammad Irfan bin Kamaruzaman and my matric number is 060567. There was a few characteristics of pipelining. First, hardware or software implementation. Pipelining can be implemented in either software or hardware, large or small scale. Stations in a pipeline can range from simplistic to powerful, and a pipeline can range in length from short to long. Synchronized or asynchronous flow. A synchronized pipeline operates like an assembly line. At a given time, each station is processing some amount of information. An asynchronous pipeline allows a station to forward information at any time. Buffered or unbuffered flow. One stage of pipeline sends data directly to another one, or a buffer is placed between each pair of stages. Finite chunks or continuous bit stream. The digital information that passes through a pipeline can consist of a sequence or small data item or an arbitrarily long bit stream, automatic data feed or manual data feed. Some implementation of pipelines use a separate mechanism to move forward, and other implementation require each stage to participate in moving information.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifin bin Mu'in Yusri. Now I will continue about major performance of pipelining. Pipelining increases the CPU instruction throughput, the number of instructions complete per unit of time, but it does not reduce the execution time of an individual instruction. In fact, it usually slightly increases the execution time of each instruction due to overhead in the pipeline control. The increase in instruction throughput means that a program runs faster and has lower total execution time. Limitation on particle depth of pipeline arise from pipeline latency is the fact that the execution time of each instruction does not decrease, put limitation on pipeline depth. Next is imbalance among pipeline stage. Imbalance among the pipeline stage reduce performance since the clock can run no faster than the time need for the slowest pipeline stage. Besides is pipeline overhead. Pipeline overhead arises from the combination of pipeline register delay, setup time plus propagation delay, and clock skew. Once the clock cycle is as small as the sum of the clock skew and latch overhead, no further pipelining is useful since there is no time left in the cycle for useful work. Next, the advantage of pipelining. First is instruction throughput increase. Second, increase in the number of pipeline stages increase the number of instruction execute simultaneously. Next is faster LLU can be designed when pipelining is used. Pipeline CPUs work at higher clock frequency than the RAM. Last, pipelining increases the overall performance of the CPU. And the disadvantage of pipelining is designing of the pipeline processor is complex. Next, instruction latency increase in pipeline processor. Besides, the throughput of a pipeline processor is difficult to predict. And last, the longer the pipeline, worse the problem of hazard from branch instruction. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif Firdaus bin Fadli. My metric number is 0618888. Okay, now I want to talk about the conclusion. In the end, the performance gains brought about by pipelining depends on two things. First, pipeline stalls must be avoided. As we have seen earlier, pipeline stalls cause the processor completion rate and performance to drop. Second, pipeline freeze must be avoided at all costs. Filling up the processor pipeline takes a serious toll on both completion rate and performance. This is especially true when a pipeline is very long but has clock rate that's comparable to that of processor with a shorter pipeline. The deep buffers that make up the Pentium 4 instruction windows described in detail here are aimed at eliminating pipeline stalls. Again, the Pentium 4 pays a relatively high price in terms of instruction tracking and buffering overhead in order to keep stalls from sapping performance. The Pentium 4 and Prescott spend a ton of transistor resource on range prediction in order to eliminate unnecessary pipeline freeze. Pipeline freeze are extremely deadly for performance on a hyper-pipeline machine, especially when the clock rate is not high enough to compensate. So, Prescott especially pays a fairly high cost in transistor and power consumption for its elaborate branch prediction logic. Furthermore, Prescott will have to scale to a significantly higher clock rate than that of the Pentium 4 if it is to perform better off-branch. Poorly predictable code at its current relatively low clock rate. Prescott is going to have a very hard time with anything but the most predictable non-branchy code types like media and gaming application, as Intel tries to squeeze another year or two out of Prescott. Expect to see it paired with an extremely large amount of on-die cache. This cache will have with branchy integral code, like that found in server application. It should also be clear at this point why Prescott is in so much trouble that Intel has turned the entire company around the embark on a significantly different course involving shallower pipelines and multi-core designs. As I demonstrate above, Frequency scaling is critical if a deeply pipeline machine is to perform well, and frequency scaling is exactly what all microprocessor companies are facing power-related problems with as the 90 nm transition. In fact, frequency scaling problems could be said to be the Achilles heel of a hyperpipeline design, and as the problems that are preventing such scaling are like the proverbial poison arrow right in Prescott Hill.